In this video, we're going to be solving Leetcode question 53, which is maximum subarray. Let's get started. In this question, we are given an array of integers, and our goal is to return the subarray that has the maximum sum. For this particular example, the maximum subarray will be here. So the values between 4 and 1. The sum of these four numbers is 6, and that is the maximum possible sum out of all the subarrays in this list. All right, let's start by trying to construct a brute force approach. When we are trying to find unique subarrays, we need to identify 2 points, which is the start of the subarray and the end of the subarray. So since we need to define 2 points, we can use a nested for loop to loop through the array and identify all the possible subarrays. So we're gonna have one pointer, the left pointer, which denotes the start of the subarray, and then another pointer, which is the right pointer, which denotes the end of the subarray. And then to count the sum of the subarray, we just need to add up all the elements between these 2 points. So that'll be 1, -3, 4, -1, and 2. And again, since it's a brute force solution, we are going to try every possible subarray in the entire list, find the sum of that subarray, and then we're going to keep track of the maximum value in a separate variable. And then we just return the maximum when we're done with this. Because we have a nested loop where we have 2 pointers in this solution, this is going to take O of n squared time to complete. So now that we have a brute force solution, let's analyze it a little bit more so we can figure out where are the inefficiencies and how we can improve it to get an optimized solution. I'm going to walk you through one iteration of our brute force approach. So our brute force approach hangs around finding the beginning and end of all the possible subarrays and then calculating the sum of those subarrays. So one iteration will be to make all the subarrays in this test to start here at the value 2. And then we're going to test all the possible endpoints of the subarray to find which of those will be the maximum. So the first possible endpoint would be right here. So this means only 2 is counted within our subarray. So then obviously the sum of the subarray will be 2. Then we're going to count the next one, which would be 2 and 1. The sum of this would be 3. So this is good because we're increasing in value. And then the next possibility would be the subarray going from 2 to -4. And now the sum of this subarray is -1. Now in our brute force solution, we're going to continue this process. We're going to continue moving this right pointer forward throughout the array. And every time we get to a new element, we're going to recheck the new subarray sum. This is a waste of time. And the reason why is because all of the subarrays that start from here and go beyond this point are going to contain these 3 values. And the sum of these 3 values, as we just discovered, is -1, which is less than 0. So if our goal is to try and create the maximum possible subarray, would we want to include these 3 elements or not? Well, the answer is obviously no, because if we include these 3 elements, we are adding -1 to our subarray. The value of these 3 elements is -1. But if we excluded all of them, then they wouldn't be contributing anything to our subarray's sum. So that would be 0. So if we were to ever find a solution, let's say this was a really good solution, and this has a sum of 5. We could automatically improve the solution by removing the first 3 values, because then this whole section goes from -1 to a value of 0. So then the entire subarray goes from 5 to 6. So essentially, once we find a subarray that has a value of, or a sum of less than 0, we no longer need to check any subarrays that start at that particular value, because we'd rather just eliminate all of the values we've already seen and start fresh. So now here is the optimal solution. Just like with the brute force solution, we're going to have 2 pointers, which indicate the beginning and the end of the subarray. The only difference is how we move the pointers when we find out the subarray sum is less than 0. So we're going to start here. This subarray indicates that the only value contained is 2. And because it's positive, we're going to move the right pointer forward. So move the right pointer forward, now it contains 2 and 1. So now the subarray becomes 3, which is greater. And we move it one more time, and we get to -4. So 2 plus 1 plus -4 is -1. Now, normally in the brute force solution, we would continue here, but we realize that there's no point in including these three values when we can just exclude them and end up with a higher subarray value. So we're gonna move both the left pointer and the right pointer so that we cut out all three of these values. So now the left pointer is gonna be here and the right pointer is gonna be here. And we basically just forget that these three values ever existed because they're never gonna be part of an optimal solution. We do the same process again. This subarray contains only the value 4, which is now a new peak. So we're gonna say 4 is our best solution so far. We're gonna move this forward and we get -1. So the value goes down, but we're still gonna continue because overall the subarray sum is over 0. Continue one more time to get to 2. And now this goes up to 5, which is a new peak. So these can go away. Move it forward again. Now this is a 6, even better. And then we go down by 5 after we add in this next element. That goes down to 1. And this is still positive, so we're gonna continue one more time to the end of the array, add 4, so we get 5. But still, 6 is the best solution. And we're done here because the right pointer has reached the end of the array. So in this solution, this is going to take O of n time complexity. Because every time we test the sum of an array, we're going to move the right pointer forward by 1. If the sum of the array is bigger than 1, we're just going to, if it's bigger than 0, we're going to move the right pointer forward. And if the sum is less than 0, we're going to move both the left pointer and right pointer forward. But every single time we're going to move the right pointer forward, the right pointer starts at the beginning, ends at the end. So that means we only look through every element at most once. So it's a linear solution. And this is much better than the brute force solution, which is n squared. So now that we have the optimal solution, we can code it up. If you're finding these videos helpful, I think you'll love what we got going on in our private community. We dive even deeper with exclusive content that won't be shared on the main YouTube channel. I also offer individualized coding interview study plans that are tailored just for you. You can also join small group sessions, participate in mock interviews, and get your questions answered in live weekly Q&As. It's a great way to take your coding interview prep to the next level. If you're interested, check the link in the description below. I'll see you inside. This is the Python solution for solving Leetcode question 53, which is maximum sub array. First, we initialize our 2 pointers to the beginning of the array. And we also initialize current sum to 0 and maximum sum to -infinity. We're now gonna start a while loop, and this while loop ends when the right pointer reaches the end of the array. In the while loop, we're going to add the newest value that we see, which is nums r, to the current sum. We're then going to update max sum if the current sum is bigger than the max sum. And if the current sum is less than 0, this is why the optimal solution is different than the brute force solution. When the current sum is 0, we're going to move both the left pointer and the right pointer out of the current subarray because none of those values can be in an optimal subarray. And we also reset the current sum to be 0. And otherwise, so this is when the current sum is at least 0 or more, we just move the right pointer forward by 1. And when we're done, so when the right pointer reaches the end of the array, we just need to return the maximum sum. So let's run the code, pass the test cases, and I'll click submit. There you go. I don't know why the runtime and memory is bad on this one. It's just sort of a random quirk, but I'll show you a submission from before. So yeah, the runtime is competitive. We get O of n time complexity and O of 1 space complexity. So that's the optimal solution.